Sharks, it's Miss Luter, just here to go over pages 375 to 376. They are on the Pythagorean theorem. They are proving the Pythagorean theorem, and it is worth 10 points. So your worksheet should look something like this, where it's got the abstract design over here. You are given the side lengths of A, B, and C. So it's giving you the measurements, and your objective is to identify, does it make a true statement, so that we can identify if it is or is not a right triangle. Your worksheet looks a little bit like this. I'm going to work through the problems with this interactive model. So we are on page 375, number 2. 375, number 2, you are given the side lengths to the right triangle to determine if each triangle is a right triangle. So we know that the measurement of A is 4, the measurement of B is 6, and the measurement of C is 8. Meaning we would do 4 squared plus 6 squared to determine if it equals 8 squared. 4 squared is 16, 6 squared is 36, and does 16 plus 36 equal 64? I can look at the ones digits right here, knowing that 6 plus 6 is 12, and that would have a one digit of 2, but this is 64 with a one digit of 4. That's just my thought process in my head. A quick way to identify that this does not equal 64. Calculator can tell us that 16 plus 36 equals 52, not 64. So even though they gave us these three pretty measurements of 4, 6, and 8, even though they're simple measurements of whole numbers, 4, 6, and 8, when we plug these measurements into the Pythagorean theorem formula of a squared plus b squared equals c squared, we can identify that this is not a right triangle. These measurements do not make a true statement. And that is your objective for this worksheet. You are proving the Pythagorean theorem, whether it works or it does not work. So on your worksheet, when you go through and plug these values into your boxes, you have to ask yourself, the square of A plus the square of B does or does not equal the square of C, right? If it does equal, then you know it is a right triangle, but if it does not equal, then it is not a right triangle. All right, so I helped you through 2A. I think you can do 2B on your own. Remember, all you're doing is taking these measurements of 5, plugging it in for A, measurements of 12 to plug it in for B, and the measurement of 13 to plug in for C, to identify if this a squared plus b squared equals c squared is a true statement or not. C is given the same measurements for all three sides. Right off the bat, does that equal a right triangle? Think about that one. All right, so I helped you through A. As long as you're taking the measurements, plugging them into the boxes, and asking yourself, does it make a true statement? Does it equal? Or if that equal sign is slashed, meaning it does not equal, then you can identify if it is or it is not a right triangle. Moving on to 376. 376 is where we are bringing back in that vocabulary of the Pythagorean triple. Pythagorean triple is when all of the measurements are whole numbers, all of the measurements are integers, and I think I lost my spot. Definitely lost my spot. Okay. So they're bringing in back the Pythagorean triple. When you are given the measurements, are they whole numbers? Are the side lengths integers? Does the Pythagorean theorem a squared plus b squared equals c squared make a true statement? If it makes a true statement, then is it a right triangle? When you have yeses to all three of those answers, then you can say that you have a Pythagorean triple. You have that grand slam of the right triangle. If any one of the answers is a no, then it is not a Pythagorean triple. All right, let's work through this. So, all right, this is 3A with a side measurement of 5 and a side measurement of 16 and a hypotenuse of 20. Can we say that the side lengths are integers? 5, 16, and 20 are all whole numbers, so yes, they're integers, right? And if I do my scratch work, if I work it out, a squared is 5 plus b squared is 16. Does that equal 20 squared? 5 squared is 25. 16 squared is 256 plus 20 squared being 400. So does 25 plus 256 equal 400? No. 5 squared 25 plus 16 256. Right off the bat, that's nowhere near 400. So that could not equal. It is not a true statement. A squared plus b squared does not equal c squared. It's nowhere close. 20 squared is 400. Doesn't equal. So it is not a right triangle. And then, of course, if you say no to anything, then nope, it is not a Pythagorean triple. Let's check. Ding, ding, ding. I got it right. All right. Here's where I've seen some confusion. When they are giving you the measurements with a square root, if they are giving you the measurement of a radical sign, first off, is that an integer? No. That is a radical sign. That is a square root of 3, and the square root of 4, and the square root of 7. The only one of those that equals a whole number is the square root of 4, because 4 is a perfect square, and you know the square root of 4 equals 2. Otherwise, the rest of them are not integers. They are not whole numbers. Well, once again, we've already found a no. So, nope, this is not a Pythagorean triple. But when you do plug these values into the Pythagorean theorem, if I were to take the square root of 3 and plug it in for a, then I have to square the square root of 3. Well, squaring the square root takes the square root away. It cancels each other out. So basically, I'm left with 3 plus 4 equals 7. And is that a true statement? Yes, it is. As long as it equals, it's a true statement, then I know it is a right triangle. All right, right triangle, but they are not integers, and as long as I have no, I have a Pythagorean triple. And down here, it's going to show you when you have that radical sign, and I square that radical sign, it basically cancels each other out. All I'm left with is the integer of 3. So I'm going to tell you one more time. If I plug the value of the square root of 4, that value of the square root of 4 into the equation for b, right there. The value of the square root of 4 squared is just 4. Think about that. The square root of 4 is 2. And 2 squared is 4. It simply undoes that radical sign. And that's one confusion, one mistake that I've been seeing most often, is that I'm seeing decimals here. And no, these are integers. These are integers. Okay, so that is 3B, which takes us to our check the understanding. check the understanding. You're asking yourself, are these measurements integers? Does the Pythagorean theorem prove a true statement? If a squared plus b squared equals c squared, then is it a right triangle? And finally, if you have yeses to all three of these questions, then is it a Pythagorean triple? Just remember that when you are given the radical sign as a measurement, if you were to square that radical sign, it basically takes it away. It cancels each other out. So you would have just the measurement of 3 and the measurement of 7. All right. If you have any questions, feel free to email me, message me on the Remind Map, or check on Teams here with me. Remember, my office hours are from 8:30 to 9:30. So I hope that this was helpful to help you through pages 375 and 376 of that spring break packet. I know I was just doing a lot of talking, but hopefully this makes sense. All you're doing is proving whether or not a squared plus b squared does truly equal c squared. If it does not make a true math statement, then it is not a right triangle. Good luck. See you soon. Bye.